Hello, Mamuna, am I audible to you? Sorry. Iram, am I audible to you? Hello, Iram.
Yes, sir, you're audible.
Okay, fine. We have to start electric flux. All right.
Yeah.
Now, electric flux. Before that, we will discuss area vector. Okay. Just a minute. Area vector. Area vector. So, let it be a planar surface. It's a planar surface. Let it be, it has area ds. ds. ds is the area. Fine. So, it is a surface. It has area ds. So, every area basically area has direction. It is a vector quantity. It has direction which is perpendicular to the given surface. So normal is always perpendicular. So area vector is perpendicular to the given surface. So just remember area vector. Area is a vector quantity having direction perpendicular to the given surface. Fine. So if I write ds vector, so ds vector is ds over n bar. The direction of area vector is always perpendicular to the given surface. So this is a surface having area ds. So the area vector will have the direction perpendicular to the given surface. Alright, is it okay?
Yes.
Now, next is electric flux. Electric flux. So what do you mean by electric flux? Let it be a surface. So electric field, this is a surface having area ds. The number of electric field lines passing perpendicular to the given surface is known as electric flux. So d phi equals to E dx. So electric flux means the number of electric field lines passing perpendicular to the given surface. Fine. Known as electric flux. Is it okay, Hiram?
Yes.
The area vector will have the same direction. Yes. So the number of electric field lines passing perpendicular to the given surface is known as electric flux. Now, this is a particular case. If we take the general case in which let it be a surface in which electric field line making an angle theta with the area vector. So in this, d phi equals to, we have to resolve the electric field. So the component which is along the area vector is E cos theta. So we can write E cos theta having area ds, it would be E ds cos theta, and so we can write d phi equals to E dot ds. All right. This is area vector. Fine. So let it be a surface having area vector ds in which electric field is making an angle theta with the horizontal. So if we have to find out the electric flux, then what we have to do? We have to resolve the electric field. Just remember one thing, we have to take which component of electric field which is along the area vector. Fine. Because the definition says the number of electric field lines passing perpendicular to the given surface. So E cos theta, d phi equals to E cos theta dot ds equals to E ds cos theta. So whenever the cos theta comes, in any formula, you have to take a dot product. It means d phi equals to E dot ds. Is it okay, Ira?
Yes, sir.
Further. Next. For continuous body, continuous body means let it be a body. This is a closed surface. Let it be a small area. This is a closed surface in which the area vector is perpendicular, that is n cap. It has area ds, ds1, and electric field making an angle theta with the area vector. Let it be even in the electric field, number of electric field lines passing to ds1. So if we have to calculate the total, then phi e means the total electric flux equals to summation I1 to n En dot dsn. Fine. It means equals to close integral. This is equals to close integral E dot ds. All right. So whenever you get a closed surface, if we have to find out, let it be electric flux as a function. Electric flux, sorry, electric field is variable. Fine. So if we have to find out the electric flux, we have to integrate with respect to area value.
Okay.
What do you mean by electric flux? Means the number of electric field lines passing perpendicular to the given surface area. Now, it is a scalar quantity. SI unit is Newton meter square per coulomb or voltmeter. Done. Okay,
Yes.
you can. How's your dot product?
Sorry?
How's your dot product? Do you know how to do dot product?
Yeah, you basically multiply the
Yeah.
vectors, right?
Before moving further, let me tell you dot product. So let A equals to A1 I cap, A2 J cap plus A3 K cap, and B vector equals to B1 I cap, B2 J cap, B3 K cap. Now, if we have to find out dot product A dot B, so A1 B1 A2 B2 plus A3 B3, because I dot I is 1, J dot J is 1, K dot K is also 1. And if you multiply I component with the J component, it will turn out to be 0, because I and J both are perpendicular. And so if to we can write A dot B equals to AB cos theta also. So if we multiply I component with the J component, I and J components are perpendicular. The angle between them is 90 degree, hence the A dot B will be 0. So we have to multiply I with I, J with J, and K with K. So this is the formula you have to remember. A dot B equals to A1 B1, A2 B2 plus A3 B3. So this is also equals to A dot B equals to AB cos theta. These are the two formulas. All right, Iram. Shall I move further?
Yeah.
The question is given. Now, electric field is now 6I cap, 3J cap plus 4K cap. This is the electric field. Fine. Calculate electric flux. Phi we have to calculate flux. Now, through the surface of area 20 units in YZ plane. Fine. So what is the direction of the area vector? Through the surface of area 20 units. It is in YZ plane. It means what is the direction of area vector? If it is YZ plane, what is the direction of the area vector, Iram? Iram, if it is YZ plane, what is the direction of area vector?
Uh,
Yes.
Direction of
Area vector. If it is YZ plane, what is the direction of area vector? X-axis. That is I cap. All right. Fine. If it is YZ plane, then the area vector will be along I cap. If it were XZ plane, then area vector will be along
Y.
Y. Now try this question. You have to use dot product and let me know the answer fast. Fast. Iram, please write your answer in chat box. Done, Iram?
Yes, sir. I'm just writing. Moment.
Phi
120.
120. Okay. How to do? Phi equals to E dot A. A is the area. So 6I cap, 3J cap plus 4K cap dot product 20 I cap, because the area vector equals to 20 I, would be 120. Okay. Is it fine till here, Viram?
Yes, sir.
Gauss theorem. Now Gauss theorem, it states that the total flux enclosed by a closed surface is Q over epsilon. Note down Gauss theorem. Total flux to a closed surface is total flux to a closed surface is over not epsilon not times the total charge enclosed by it. That is phi equals to flux is Q over epsilon. This is Q net. Okay. So this is a statement. Look. So let it be a charge. Okay, let it be a charge. First of all, if it is closed, it is a Gaussian surface. Later, I'll let you know what do you mean by Gaussian surface. Let it be a Gaussian surface. It is a closed figure. Just a minute here. Sorry. So it states that phi equals to Gauss theorem states that the total flux through a closed surface is 1 over epsilon times the total charge enclosed by it. So phi equals to Q over epsilon. So let it be a charge enclosed by a Gaussian surface. Let it be a sphere. It is a sphere. Gaussian surface must be symmetrical, having radius r. Now the total charge, if we have to calculate the total flux through this surface, then it would be Q over epsilon. Fine. Now we have to show it. Now proof of this theorem is very easy. Since I told you by the definition, phi equals to E dot dx. All right, so let it be a Gaussian surface. What do you mean by electric flux? What do you mean by electric flux? Means the number of electric field lines. The number of electric field lines generated by this charge is known as electric flux. Fine, that is Q over epsilon. Okay, Iram. If we have to calculate the
Yes.
total, fine. So let it be a charge. Now, let it be. Now it is surrounded by a Gaussian surface. It is an imaginary, it is an hypothetical surface, and it must be symmetrical. So if it is a charge, if it is a point charge, then we have to assume a spherical Gaussian surface. Fine. So let it be a Gaussian surface having radius r. It is a sphere. Let it be a small portion having area ds. Area is ds. Now due to a point charge, this is positive charge. Now Iram, let me know what is the direction due to this positive charge. What is the direction? Away from it or towards it?
Away.
Yeah, away from it. So electric field will be in this direction, and area vector will have the same direction. All right. Now, so pi e equals to e ds. This is known as closed integral. All right. Known as closed integral. Fine. It is a closed surface. Fine. So what is the direction of area vector in electric field? 0 degree. Same direction, cos 0. All right. So E ds. What is the area of the sphere, Iram?
2 pi.
Sorry, area of sphere, not circle.
Sphere. 4 by 3.
4 pi r square. Okay. And what is the electric field due to a point charge? Look, it is a point charge, and if we have to calculate the electric field at a distance r from this charge, then what is it? What is the formula for it? 1 over 4 epsilon q over r square. All right, this is the formula due to a point charge. Now r 4 pi cancel out, so q over epsilon. So flux equals to q over epsilon. As I told you, the total flux through the total flux is equals to 1 over epsilon times the total charge enclosed by the closed surface. This is Gauss theorem. Did you get it? Is it fine, Hiram?
Yeah.
Shall I proceed?
Yes, sir.
Just a minute. Now, first is, for example, give an example. So let it be a closed surface. Closed surface. This surface contains 2 microcoulomb, one is 3 microcoulomb, 1 microcoulomb. Now the question is asking, calculate the total flux. Fine. So phi E must be equals to Q over epsilon Q total. What is Q total? Minus 3, 0. All right. 2 minus 3 plus 3 is total charge enclosed is 0. What is Q total? 2 microcoulomb minus 3 microcoulomb plus 1 microcoulomb.
Yeah, see.
0. So the total flux will be 0. How to use it? Okay. Is it fine?
Yes.
No. Note. First, if net charge, that is Q total, enclosed by the surface is 0, then phi E is also equals to 0. Okay, because the charge enclosed by the surface is 0, and the electric flux must be 0. Second, is let it be a surface. Fine. If we change the medium, for a medium having dielectric constant. So for a medium having dielectric constant K, flux through the medium equals to phi dash, let it be phi dash equals to phi over k. All right. If we change, let it be a surface having flux phi. And if we change the medium, then the flux will be phi over k. I'll give you an example. Is it fine?
Yeah.
Okay. Remember one more thing, Ira. If I tell you, if I ask you, let it be, if the total charge enclosed by the closed surface is zero, will the electric field will be zero or not?
Yes.
Yes, but why?
Because the charge is zero, right? So how can any electric field be produced?
Look, if the total charge enclosed by the electric field, if the total charge enclosed by the, if the total charge enclosed by the surface is zero, then flux will be zero, but net electric field will not be zero. But electric field be zero. All right, look why. So let it be a surface minus q and plus q. It is a dipole. Fine. What is the total? What is the total charge enclosed by the surfaces? It would
Zero.
zero. But if we calculate the electric field at an axial point, so there will be an electric field. I told you due to an electric dipole, the electric field at an axial point. Do you remember? If we can easily calculate the electric field at an axial point due to this dipole. But the total flux enclosed by the surface is zero, but the electric field is not zero. Look, let it be a point at an equatorial point. There must be some electric field within the surface. I told you the electric field due to an electric dipole at an axial point or equatorial point. So let it be a point within the surface. Let it be a point within the surface at equatorial. Fine. So there must be an electric field. Fine. But the total flux is zero, but the electric field is not zero. So just remember one thing. Fine. If the total flux enclosed by the closed surface is zero, the electric field need not to be zero. Okay, because if it contains a dipole, but electric field need not zero. All right. Is it fine?
Yes.
Did you understand, Iram? Okay.
Yes.
Now let me. Scalar sorry. Electric flux is a scalar quantity or vector quantity?
Scalar.
What's its SI unit?
Uh, Voltmeter
Or Newton meter square per coulomb.
yeah.
What do you mean by electric flux?
Number of electric field line passing perpendicular to the given surface.
What, what is the formula for it?
D phi is equals to EDS.
Great. If the total charge enclosed by the closed surface is zero, the electric field must be zero. If the total charge enclosed by the surface is 0, then the electric flux is 0. Will the electric field be 0 or not?
No, it won't.
Because, example, if it
Because
encloses an electric dipole. And next is Gaussian circles. Gaussian circle. Now, Gaussian circle. Any hypothetical surface, fine, enclosing a charge is called Gaussian surface. Fine. It is an hypothetical. Is it okay till here?
yeah.
Now question. Now calculate the flux. Calculate the flux. If I ask you the number of electric field lines is similar to flux, all right. If the question is asking calculate the number of electric field lines, it means the question is asking about the flux. So calculate the flux originating from one from of from a charge of 1 coulomb. Please, 1 minute. Like you have to apply the formula directly. You'll get the answer fast. Calculate the flux. Iram, please let me know the answer. Pi equals to
1.29.
just 1.29. Yeah,
1.2.
1.129. What is charge? 1 coulomb. And epsilon value is 8.854 10 to the minus 12. Iram,
Yes.
we did not discuss electric field lines properties. Did we discuss?
No.
Okay. In the next class, we will discuss. First of all, we will discuss the electric field lines properties.
Okay.
Okay. Now, if you solve it, you will get 1.129 10 raised to power. Do you know how to solve it?
Yeah. I know.
Yeah. 11 voltmeter. This portion is most important in electric field and lines. Gauss theorem. Next is applications. In the next class, we will discuss the numericals. Application of Gauss theorem. Applications of Gauss theorem. Now, but first of all, we will discuss all the numericals based on Gauss theorem. Now, first application is electric field due to uniformly charged thin line wire. All right, there are just two applications are in. So let it be a wire infinitely long, positively charged. It can be negatively charged also. Now we have to imagine a Gaussian surface. It is a hypothetical surface, all right? So just remember which Gaussian surface we have to assume, which is symmetrical. Fine. So it is cylindrical. So it is symmetrical. The question also asks if it is a uniformly charged line wire, what is the shape of the Gaussian surface? So it must be cylindrical. Having length L, and now we have to calculate the electric field at a distance R. So it is a uniformly charged thin infinite wire, which is positively charged. This is a Gaussian surface. Gaussian surface. So if the question comes in your exam, what is the shape of the Gaussian surface? If 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 it is uniformly charged thin line wire, so it must be cylindrical. We have to calculate the electric field at distance R. So there are three surfaces. One is curved, two surfaces are circular. The direction of electric field for curved portion towards right, electric field towards right. This is electric field. This is electric field. The area. Okay, Iram, let me know what is the direction of the area vector. Let it be first surface. This is first surface, this is second surface, and this is third surface. Now let me know the direction of the area vector for the first surface.
Up straight, like above.
Yeah, perpendicular.
Perpendicular, yeah.
ds vector. And for this surface, along the area vector, along the electric field. And for this,
Down.
yeah, must be in the downward direction. This is 2. Now why the definition? Phi equals to the electric flux through the closed surface is E dot ds. Now there are three surfaces. So EDS S1 plus EDS S2 plus EDS 3. Is it okay, Iram? We have to treat separately. Now, EDS1. What is EDS1? What is the direction between area vector S1 and electric field? Please, Iram. What is the direction? Perpendicular. So EDS1 cos 90. Likewise, EDS2 cos 0 because both have same direction. Likewise, EDS3 cos 0. Just that. Sorry. So EDS1 cos 90 plus EDS2 cos 0 because both have same direction. E ds3 cos 90. What is cos 90, Iram?
1.
Cos 90 is 0. All right. It would be 0. Cos 0 is 1.
1.
1. And cos 90 is 0. Now, what is the curved surface area of cylinder? What is the curved surface area of cylinder, Iram? 2 pi RL. R is the radius. Fine. R is the distance basically from the wire at which we have to calculate the electric field. So E into 2 pi RL. Now by Gauss theorem. Most of the time, in most of the books, it is written, it is Gauss law. It is not a law, it's theorem. All right. And teacher also by mistake, they use the word Gauss law. It's Gauss theorem. And law doesn't have proof. Gauss theorem. So phi E equals to Q over epsilon. Let it be Q is the total charge. Okay. And just remember one thing. Lambda. It has density lambda. That is linear charge density. Linear charge density. And what is linear charge density? Do you remember, Iram? Now this is, let it be first, let it be second. So from first and second, we can say E into 2 pi RL equals to Q over epsilon. Do you have any doubt till here? Then we will proceed.
No.
Okay, further. So we can say Q over 2 pi epsilon RL. We can if we rearrange, so 2 pi epsilon R, just a minute. Q over L. What is Q over L? Iram, what is Q over L? Lambda.
Lambda.
So lambda equals to 2 pi epsilon R. This is electric field. Is it fine?
Yes.
We can conclude E is inversely proportional to R. Now, if we have to plot the graph between electric field and distance, it would be hyperbola. Okay, because inversely proportional. This derivation is important. This graph also. Is it fine?
Yes, sir.
Okay, next. Next derivation is electric field due to infinite plane sheet. Due to uniformly charged in infinite plane sheet. All right.
Yes.
Let it be a plain sheet, uniformly charged. But we have to calculate the electric field due to this uniformly charged thin infinite sheet. So again, we have to assume a Gaussian surface. The Gaussian surface will be cylindrical. Fine. Let it be cross section A. Cross section A. Now area vector. What is the direction of what is the direction of electric field due to positively charged sheet? Towards it or away from it?
Away.
So electric field will be towards, and area vector will have the same direction. Fine. Having surface charge density sigma. Surface charge density. This is Gaussian surface. Okay. What is the shape of the Gaussian surface? Cylindrical. Okay, Iram.
Yes.
Again, we will use two things. First of all, we will find by the definition. So by definition, flux equals to E dot ds. So there are three surfaces again. Due to this surface, now due to left surface, the electric flux will be E times A. Due to the curved surface, the electric flux will be zero because the electric field is towards right and the area vector is perpendicular to the surface. The angle will be 90 degree, hence the electric flux will be zero. Due to the right, again E times A. So total is E times A. 2E times A. Is it fine?
Yeah.
Now by Gauss theorem. So by Gauss theorem, phi E equals to Q over epsilon. Q is the total charge. That would be second, would be first. So from first and second, if we equate okay, 2 times A equals to Q over epsilon gives you E equals to Q over 2 epsilon A. And what is Q over A? Sigma. Since I told you sigma equals to Q over A. Fine, surface charge density. So, and the electric flux is 2 over epsilon. So, by this formula, we can conclude the electric field is independent of the distance. All right. Whether the point lies R1 distance means 2 centimeter or 200 meter, the electric field will be same. In case of thin uniformly charged sheet. Is it fine, Iram?
Yeah.
So we can draw two conclusions. First, independent of distance from the sheet. Fine. If sigma is greater than 0, it means if the sheet is positively charged, then electric field will be away from it. Okay. In B, if sigma is less than 0, then electric field towards the sheet. All right. If it is positively charged, then away from it. And if it is negatively charged, then towards it. Is it fine?
Yeah.
Okay. Now, if I ask you, just a minute. It's a tricky question. What if it comes in exam in MCQ? If we plot the electric field versus distance graph in case of thin in in case of thin uniformly charged sheet, then it would be a straight line. What is the shape?
Hyperbola.
No, it would be like this because the electric field remains constant. Okay, it doesn't depend on R. It depends on surface charge density and the medium. All right, permittivity is the medium. Fine. So if we plot the graph between electric field during uniformly charged sheet, then it would be like a constant. It would be parallel to the x-axis or parallel to the distance axis. All right, Iram?
Yes.
Okay, just a minute, Iram. Let me give you some homework. Now, electric flux question number second. Try at home. All right. And third also. Second and third question, try at home. All right.
Yes.
Okay. Bye.